Hello everyone. I hope you're all having a good day. I'm Surya Vamshi R. Some of you might know me, some of you might not. So this video series is based on my master's project which I did under the supervision of Professor V. Subramaniam of University of Hyderabad. It is titled S25 Quantum Protocols and Various Metrics, where I introduce S25 in its very primitive form and some of the basic metrics associated with it. So since then, there has been some modifications in how what is the method that I use for testing protocols, as well as some of the methodology, and also to S25 itself. There has been some new modules coming in, which actually synergizes well with the S25. I would like to make this series explaining all of these nuances, and uh, I am planning to write this paper to IEEE or Journal of Quantum Cryptography. So the reason I chose video series is because there is a lot of theory involved. So there is theory in why the assumptions are what they are, and there is theory as to why this protocol works. There's also spaces, attacker space, receiver space, and also various other theoretical nuances that has to be explained. And it cannot be done through a paper, as it would be very long compared to IEEE format. Okay, so this contains a different modules such as language aspect. There is a quantum aspect. Then there is laser physics involved, and then there are also neural networks, AI, and classical cryptography as well. So this is just the basics, and this is what I'll be explaining throughout the video. One, I'll be going over basics of quantum mechanics. So again, this is a lecture. This is to keep in mind both the fields of classical cryptography and for physicists to follow through. So I will be going over the basics of quantum mechanics. Then I'm going to go into quantum computing and certain circuits. So then I'll be having a brief talk about quantum error corrections. So, and then this is the basic basis for which I'm going to be starting. So next I'm going to do is just put a line. So I'm going to talk about the assumptions and physics behind it. So next I'm going to be talking a little bit about why we need quantum cryptography and why can't we just use classical cryptography. So why quantum cryptography? Next I'm going to be talking about attacker strategy and failure of certain protocols. So six, attacker strategy and failure of other quantum protocols and some classic protocols as well as post cryptographic methods as well. So then I would be, so this is the introduction or the prelude to the actual series. So after this I will be explaining about S25. So then I will be explaining about basics of or introduction to S25 with a flow chart that everyone can follow through. So after that, I will be looking at various steps of it and explaining what exactly goes behind every single step. Again, this is going to be a very brief explanation, as I'm going to be explaining every single aspect of these steps in the following modules. So then I will be explaining about the quantum aspect. So then I will be explaining about what happens if I take it to higher dimensional information entities such as qubits and so on, and of course how that is going to influence the security measures. So of course, right now with the current technology, qubits are not stable, but once we do achieve stability, we can have some advantages and increase in security measures in this particular protocol, as well as other protocols such as BB84 and so on, that I will be touching upon. And then I will be going into the actual classical cryptographical part. So this protocol unites both classical cryptography as well as quantum cryptography. So here I'm going to be talking about one of the steps, which is generating the file, and also the physical bottlenecks and some of the solutions which I'm going to offer. So right after this, I will be looking at encryption decryption process. So, of course, we need to look at what these strategies are and then how I'm going to bring about in this particular step. And then I will be looking at language redefinition module or LRM. So, this is one of the new modules not introduced in the primitive version. Then I'm going to be looking at the cascading function. Also, there is a theoretical proof as well as a physical proof. Physical proof is, the coding part of the proof is going to be presented at the very end of the video. Then I'm going to be talking a little bit about AI. So, where AI is going to be used and how is it going to be used. So, this is the explanation of all of the S25 itself. So, right after this, I'll be switching over to the performance metrics and things like that. So then the next thing I'm going to be looking at is performance. First, I'm going to be looking at maximum mutual information in arbitrary implementation, and I will get to what that exactly means. So let me just write MMI. So the next one, of course, this MMI is different from the ones in neural networks and cryptography. Uh, Maybe I have to name it something different, so we can look into that later on. So next, I'm going to be looking at resources used. So right after this resources used, uh, this is going to be the theoretical part, and there is some slight amount of practical example that I can give. So I'm going to use LRM and attacker space modeling. So we are just going to look at a very simplified case of LRM implementation and what the attacker sees with everything. So this concludes the um, whiteboard part of this, and the next one I'm going to be switching over to my laptop where I'll be looking at a pseudocode. Then I'm going to be looking at a demonstration of the code. So here we can see all of the performance metrics being into play, and also there can be there is also the time between every communication and etc etc. Uh, Again, while doing the demonstration, we can compare it to the theory which I have explained previously. Then I'm going to talk about some issues. So during the development of the code, there are some issues which I've faced, and yes, it is going to remain an issue for now until we actually get the hardware for quantum computers. So then we are going to look at further testing. So this is just the preliminary test which I have done. We can look at further testing using actual qubits, or we can use Qiskit or Quasum or some other module. And we're also going to be looking at what happens if I inject noise, and etc. etc. And then finally, we're going to look at the conclusion. So this is the introduction part of the video done. Now let's move on to the next part.